Okay, we're in the homework and it's section 13 now. I'm going to move to the whiteboard and I'll do questions one by one. I may not do every detail of the question. Certainly, if you do need additional support for whatever reason, please come by during office hours and I'll be more than happy to help you. So just give me 1 second to share my whiteboard with you. And again, we're not trying to trick you. So we're on question number one, and question number one is, express the arc length of the curve on the given interval, but it does stress that you shouldn't be evaluating this. So the first thing I would probably do is just, I'm starting the problem set. So I'd probably draw a picture, and the picture is going to be between 0 and pi/3. So tangent curve sort of looks like this. So this would be 0.00 here. And the other point would be, what's that going to be? It's going to be pi/3, right? And let's see, if you did pi/3, let's write this down. It's going to be 2. Y is going to be 2 tangent pi/3. That's 60 degrees, so it's going to be 2√3. Now, I realize some students are asking a question, do I need to graph it? Not really. We're not trying to trick you. So how do I do the arc length? Well, I'm going to write this down for you. It's going to be pretty simple to write down. We've derived the formula already. So y is going to be equal to tangent, oops, I forgot the 2, of x, and dy dx is going to be 2 secant squared x. So I think I can write the integration down. What's it going to be? Well, we're going to move along the x's. That's going to be from 0 to pi/3. 1 plus its derivative squared. Well, the derivative squared is going to be 4 secant to the 4th power x dx. And again, they didn't say it. They didn't say evaluate it, which I'm glad, because I wouldn't want to struggle with that guy. And what are you going to do? Check to see if you have the right answer. And do we? Let's see, 1 plus 4. Yeah, we did it right. Let's go next question. And again, be careful what their questions are. So this one's over here. Again, I'm not saying you have to draw a picture of it, but I'm just gonna get a feel for it. And what do you get? A little picture over here. So it's starting at 1, 1. Because if I plug in 1, I get 1. And 3 would be 3 to the 3 halves. And that's going to be the square root of 27. It's around 5 or so. So it's up here somewhere. I want to point out there's a connection between the two. All right. Now, I'm not going to, spend time getting the connection, but there's a connection between those 2 points. And I'm just going to write down what I'd write down. And what do I need to write down to do the problem? Well, I need to write down dy dx. And that would be 3 halves x. That'll be 1/2, right? And then I square it. And if you square that, you get 9/4 of an x. That was pretty easy. Now I add 1 to that. And 1 plus 9/4 of an x. Well, it seems pretty simple. And then what I'm going to do is put the integration down. And it's going to be between 1 and 3. We'll look at the answer later. It's going to be the root 1 plus 9/4 of an x dx. Let me do a u substitution here. Again, if you can do it quickly, please do so. We're not suggesting this needs to take a lot of time. And that means 4/9 of a du is dx. When we write this over here, we'll look at the answer later. So 4/9, I'm going to the land of u's, du, u to the 1/2. Let's see, if I put a 1 there, what would I get? I'd get 13/4. And if I chose 3, what would I get? 27/31/4. Again, if the arithmetic gets too difficult, I'm not going to do it, but I think I can handle it. So it's going to be 4/9. U, I have to increase it by 1, that's 3 halves. And divide through by 3 halves, which is multiplied by 2/3. Limits of integration are going to be from 13/4 up to 31/4. Again, if you're better with arithmetic, I would say walk away. I'm better with arithmetic, but I'm not going to walk away. That's 8/27. And I'm going to evaluate that u to the 3 halves. I want to emphasize that u to the 3 halves is u root u. That's what that means. So what do I get? I would get 31 quarters times, let's see if I did that right. 2 times 4 is 8, 27. I did it right. So 31 quarters is u, and then the square root of that would be root 31 halves minus, I'm going to do 13 quarters now. So it's 13 quarters, root 13 halves. The worst part about doing it is mistakes happen. So I'm going to write this over here as 1/27th now because I see the 8's canceling. And what he left off with 31 root 31 minus 13 root 13. All right, let's see how we did. And again, if I make a mistake, I'll have to correct it. Let's see, did I do that? 331, 13, 13. Yeah, bingo. Got it. All right, let's do this one over here. We'll complicate it. And what I mean by complicated, I have to, they're not tricking. I can assure you that. It would be awful to trick a student at this stage. So I'm looking at the natural log and the cosine of 16x between 0. Well, if I plug a 0 in, that cosine of 0 would be 1. So that's fine. I can take natural log of 1. And then pi over 48, if I did that, that would be pi over 3. Oh, so certainly the number, cosine 16 in that domain there would always be a positive number. So I'm pretty good. So let's go through the work then. What's the work going to be? Well, y is equal to 1/16 times the natural log of the cosine of 16x. So my first goal is to get the derivative, dy dx. What's 1/16 times, let's see, the derivative of natural log is 1 over its argument. So it's going to be cosine 16x. And then I'm going to take the derivative of the argument, which is going to be minus sine 16x times 16. Well, this simplifies nicely to just minus tangent of 16x. That was pretty simple. Now, what am I going to do? Square both sides and add 1 to it. And what would that give me? 1 plus tangent squared 16x. I hope that's not a big struggle for you. And what's going to give me? Secant squared 16x. That's an identity that you should know about. So I'm going to write that down. What is going to be the root of secant squared 16x dx. What are the x's moving between? 0 and pi over 48. Well, I gotta be careful about this because the square root of the secant squared is actually the absolute value. But in that range of numbers, it's going between 0 and pi over 3. It's going to be positive. So this looks like a fairly easy integrand. I just may not be able to remember what its antiderivative is. All right, I'm going to keep going. I'm going to say u, 16x, du would be 16 dx, or 1/16 of a du would equal to dx. Now let's write this down. And what's that going to give me? Well, if x is 0, u would be 0. And if x is pi over 48, it would be pi over 3. And I get secant of u. Now what's dx? It's 1/16, right? Of a du. Now, by the way, this is where I would say a lot of students would get stuck. They say, I can't go on. Walk away. Or raise your hand and say, hey, what's the antiderivative of the secant? And I would tell you. I would actually say, oh, I wouldn't say you're right or wrong, by the way. But if you're on exam and say, hey, what's the antiderivative of secant? I would write it on the board for you. All right. And I want to point out, I can't remember a lot of stuff too, but I'd say, oh, the secant of theta, d theta, its antiderivative is the absolute value of the natural log of, I'm sorry, I got the absolute value in the wrong position there. Give me 1 second. It's going to be the natural log, absolute value, secant theta plus tangent theta. I would tell you that. All right. No doubt about it. Did we draw that in class? Of course we did. Would I expect someone to remember that? I don't think so. I don't think I'd want to remember that either. You know, could I derive again? Yeah, but it's exhausting to keep deriving things over and over again. So what I'm going to do now is, you know, I'm going to write it down and write this down very quickly for you. So what do you get? 1/16. Let's see, natural log, absolute value, secant, not theta. It's going to be u, right? Plus tan u, absolute value. That's going to be 0 to pi over 3. It's exhausting. We realize that. 1/16 natural log. Well, the secant of pi over 3, let me remind you, that's pi over 3 is, that's 60 degrees, right? Something like this over here. That would be √3. This is 1, that's a 2. So that would be 2, right? So put this over here. And the tan would be √3. That's pretty good. Minus 1/16 natural log, absolute value. Well, the secant of 0 is 1, and the tan of 0 is 0. The natural log of 1 is 0. Wow, this is easy. So what do you have here? 1/16 natural log. 2 plus √3 is a positive number, so I'm not going to remove the absolute value symbols. Now, could I have made a mistake? Of course. Let's look at our answer key, and I want to see if I got that right. Yeah, bingo, got it right. Again, on exams, if you ask a question that I think you should answer, I wouldn't tell you right or wrong, by the way. Like if you said, what's the antiderivative of, I don't know, the natural log, I don't know if I'd give you that one, but I could write that on the board too for you. But I wouldn't say it's right or wrong. I just would say, yeah, maybe if you want to use it, try it, give it a try. All right, let's do this one over here. As I'm doing it, I'm kind of thankful for the pictures. And I'm going to say that what they want me to do, and I'll point out, they want me to go between 0 and the point in that curve is going to be 0, 0. By the way, this point over here, just looking at this thing, that's the curve. This is going to be 3, 0. All right. But they want me to go up to 2. So they want this section, whoops, of the curve. And what's this point over here going to be? Oh, it's going to be 2 something. Someone said, could you plug that in? I guess we could. I don't know if it's important though, but you could compute it. What do I have to do though? And what I have to do is I have to do the arc length of that. And I'm going to do it a little bit different than it's done in the notes, by the way. And the reason that some students do it different than they do in the notes. And what I'm going to do is I'll write this over here. So I'm going to write down 9y squared equals x minus 3 squared. And I'm going to differentiate both sides using implicit differentiation. 18y dy dx equals, well, let's get a little trouble over here. It's going to be x minus 3 squared plus, let's see, that would be 2x x minus 3 times 1, and dy dx is equal to x minus 3 squared plus 2x. And I realize some students are going to say, this is not working for me. Maybe not. I'm not saying it is. What I'm going to do is I'm going to factor that because it looks a nightmare to me too. So x minus 3 comes out. And what he left off with, x minus 3 plus 2x over 18y. Let me keep going. I know it's a lot of work. We're not saying it's not a lot of work. Our goal is to encourage the work though. So 18y, and on top, I want to point out this is 3x minus 3. I'm going to factor a 3 out. So you would get x minus 1, x minus 3. And I have to square that, right? But before I do that, I notice that this thing cancels to a 6. So let's write down dy dx squared. And what do you get? 36y squared. And then what do you get over here? X minus 1 squared, x minus 3 squared. Now what I got to do? I got to add 1 to that. So 1 plus this. And I know it's looks crazy to you. I assure you they work out beautifully. So 36y squared, 36y squared plus x minus 1 squared, x minus 3 squared. Now, what I'm going to point out over here is that I think I've seen this guy before, the y squared. And where is it? It's right up there. It's 9y squared. So I'm going to write this as 4 times 9y squared plus x minus 1 squared, x minus 3 squared over 4 times 9y squared. Now, what's 9y squared equal to? X minus 3 squared. Yeah, I know it's work. Worst part about work is if you don't have it. All right, I got to do some, I have more and more work. It's endless work. All right. So what do? I would probably divide through by x minus 3 squared. And what would you get? Well, 4x plus x minus 1 squared. By the way, after doing all that work, you may say, I don't even know why I did all that work. And it's possible. You do work and at the end of the day, say, why did I do that? I don't know. Keep going. Well, top's going to be x squared plus 2x plus 1, which is a perfect square, right? Which is x plus 1 squared over 4x. Someone said, what did you just do? We just did this. Now what I got to do? I did square root of that number. And if I did that, I'll write this over here. And if you recall that the x was going between 0 and 2, let me go back to that. And what do I know? I know that this looks like it's doable. I want to point out that x plus 1 on the interval between 0 and 2 is never going to be like x plus 1 is never going to be negative, nor is 4x going to be negative. All right. Now, granted, I realize that that 0 on the bottom might be bothering you, but let's not worry about it yet. All right. Let's not worry about it yet. And let's just take a look. So I'm going to write this over here. 0 to 2. And what do you get over there? Let's see if we can do that. And you would get x plus 1. And the bottom, you get 2 root x. Again, I'm going to continue to simplify it. I know it's annoying, but I want to do it. I'm going to pull a 2 out. And this would be root x, which is x to the half, plus x to the minus 1/2. Now, by the way, I know this is an improper integral. And really, formally speaking, I should write it down as a limit. I think in my notes I don't do that. But I want to point out, no matter what I do, there's going to be work getting to that integration. And I'll put this over here and tell you where it is. And that integration is right over here. All right. Did I get the same one? X to the half, x to the minus 1/2. Yeah, same one, 0 to 2. Now, granted, I got to warn you about this too. Many of your teachers later on, like in upper level courses, never write down the limit. They might say, oh, it's improper, but I pretty much got this one covered. But I'm going to write it down. All right. So 1/2 limit as R. This goes back to the improper integration problems again. 0 from the left side. All right. And let's write this over here. Antiderivative. X. Let's say I increase it by 1, 3/2, right? And then divide by 3/2, multiply by 2/3. Plus x, increase that by 1, 1/2. Divide by half or multiply by 2. And this is going to go from R to 2. Now, again, my opinion, and again, I don't have, infinite experience, but I have enough experience sitting through lectures where the teachers would not have written down the limit for that. And I didn't do it in my notes either, by the way, so I'm just as guilty. So what do you get over here? Let's see if we can do it. And, certainly it doesn't look too bad to do. I'm going to write this over here. So it's going to be 2, and 3/2 is 1.5. So it's going to be 2 root 2 over 3 plus 2 root 2. And I want to point out if r is going to 0 from the right, both of these things exist and their limit would be 0. So I'm not going to write that down, minus 0. Right, so that was pretty simple to do. Let me clean it up a tiny little bit. And if I did that, I would get, oh boy, I got to do arithmetic now. 1/2 4 root 2 over 3 plus 2 root 2. I'm going to factor out 2 root 2. So 2 root 2 over 2. And you would get 2/3 plus 1. I hope I don't make any mistakes with the arithmetic. Oh, that's just root 2, right? And then 2/3 plus 1 is 5/3, right? And that's going to be 5/3. Make a mistake, I'll have to go back and look at it again. 5 root 2 over 3. Did I get that? Yeah, miracle. Got the arithmetic correct. I really mean that. For the most part, going through that manipulation of algebra is not that bad for me. It's the arithmetic that kills me off. It really does. All right. So that's number 4. Let's go to number 5. Number 5 is an interesting problem. And I'm going to go through it. Now, when I'm doing this thing over here is that I realize there's a tremendous amount of symmetry to this problem. Let's take a look. I'm just going to maybe just do one portion of it. And so I'm going to talk about this portion over here. All right, let me get my little red pen out though. And there's 4 of them. So I'm going to say there's a point there and a point there. And I want to get these points. So the point would be, well, if x is 0, the y would have to be 5. And over here, if the y is 0, the x would have to be 5. That's pretty simple to look at the equation. Now I'm going to set up the integration now. And I'm looking, I wonder how to do that. And I'm going to use that implicit differentiation again, right? And I'm hoping it's going to work out really nicely. So what do you get over here? And by the way, what I'm saying, I'm hoping the reality is we write problems, or I should say we select problems. These are problems that are used over and over again. I think you can find any textbook in the universe and they'd probably have a problem like this. They might change the numbers a little bit, like the 5 might be a 6 or a 7. It's not a substantially big difference. Let's implicit differentiation. What do you get? 2/3 x, I got to take 1 away from that, so it's minus 1/3, plus 2/3 y to the minus 1/3 dy dx. The derivative of 5 to the 2/3 is 0. Well, dy dx, I got to solve that, is going to be minus 2/3 x to the minus 1/3 divide by 2/3 y to the minus 1/3. Boy, it's a lot of work. Dy dx is going to be minus y to the 1/3 over x to the 1/3. All right, I hope I didn't go too fast with that. But again, the thing is, if it goes too fast, you simply say, I got to think more about that. I got to do more work. I got to start to practice. What do I got to do now? I got to square that. And what do you get over there? Oh, that's easy. Y to the 2/3 over x to the 2/3 when I square that. Then I got to add 1 to it. And what's that going to be? Well, common denominator, x to the 2/3, x to the 2/3 plus y to the 2/3. Boy, that looks familiar. Have I seen that before? X to the 2/3 plus y to the 2/3. You sure did. What is it? It's 5 to the 2/3. Let me write that down for you. What do you have to do with that? Take its square root. And what is this going to give you? 5 to the 1/3 x to the 1/3. All right, that's not so bad. All right, what would you just do over there? Well, I did that, I got the integrand. And what's the integrand going to be? Well, I'm going to put the cube root of 5 out on the side. And this is going to be x to the minus 1/3. It's going to be dx. And what's my limit integration going to be? 0 to 5. By the way, this is also an improper integral. And again, a lot of teachers don't bother writing it down. Just for sake of argument, I will write it down for you. So it's going to be 5 to the 1/3. You know what I should do though? I should look at the keys on the other page. We'll do it later. Oh, by the way, I'm sorry, that's only one region of it. I got to multiply this by 4. All right, let's do that. So what do you get? 4 cube root of 5 times the limit r goes to 0 from the right side. You know what? I get back to the other question. Maybe I made a mistake in the other question. Did I do my limit? Let me take a look. I remember doing some limit problem. I was wondering if I put the right direction in. Just can't remember where it was. I'm sorry, I made a mistake in this one over here. It's not the left side of 0, it's the right side of 0. And I apologize for that. So you make mistakes, you think back at your mistakes. Story of my life, by the way. All right, I corrected it. So let's take a look at this one over here. And you're going to get, let's see, R 5, and this would be x to the minus 1/3, d, not dx, not dy, it's dx. Sorry about that. I think I can do it. Let's see, whoops. Increase it by 1, 2/3, right? And divide through by 2/3, multiply by 3/2. Limit integration r to 5. I think I can do it. I'm going to pull a constant out. You're going to get 6 cube root of 5. Again, I'm not beyond making mistakes. 2 times 3 is 6 cube root 5. And then I would get, let's do the upper limit. That would be 5 to the 2/3. And then what would I get for lower limit? Well, the r is going to 0 from the right, and this is certainly doable. It's going to be 0. So what do you get over there? Let's write this down. 6 cube root of 5. And that's going to be 25. It's going to be 30. Wow. I don't know. Maybe a mistake. Let's go next page. 30. Bingo. We got it. And completely a miracle. I really mean that. Mistakes happen. And you're going to notice when you're doing homework, mistakes happen. You know, I always say if you're doing homework, a lot of students don't do homework. They think they don't have to do it. They think they're beyond that. Just like a lot of people, you know, if you look across the board, you know, around the world, do people exercise? Some people do. Most people don't see the benefit to it, though. And the fact is, there may be no benefit to exercise. And I always say the benefit of exercise is that, you know, healthier living for the most part. All right. So let's say compute the surface area. Oh, this is a surface area problem. So I think I know what I have to do. You know, certainly you know, my really bad visual skills. I draw a really crappy picture over here, cube function like this. I draw a strip in there just to remind me what this thing looks like. All right. So let's write this down. And I'm getting much better at this. So I'm going to say 0 to 6. Now, the radius of that strip is actually going to be y. So it's going to be 2 pi y. But y is actually x cubed times, it's going to be dx, the arc length of that. And that arc length is going to be 1 plus its derivative squared. What's the derivative going to be? 3x squared. Well, looks like a tough one. So again, if the numbers get really difficult, I'm gonna bog down and say I can't do that. Let's take a look at this. 2 pi, 0 to 6, x cubed, and what do you get over there? 1 plus 9x dx. I got to use u substitution, and this is where I'm probably going to bog down. So u equals 1 plus 9x4 du equals 36 x cubed dx. So 1/36 of a du would equal x cubed dx. Let me see if I can do it. 2 pi. Well, if I plug in 0, I get 1. Plugging in here, by the way. If I plug in 6, I can't do it. I'm just too tired. 1 plus 9 times 6 to the 4th power. What's x cubed dx? It's 1/36 of a du. All right. And then what do you get? You're going to get u to the half power. I'm going to keep doing it. Pi over 18. And then you have to increase it by 1. So it's going to be 3 halves, right? Divide by 3 halves or multiply by 2/3. And that's going to be from 1 to 1 plus 9 times 6 to the 4th. I'm not going to do the arithmetic, by the way. What do you get up there? Well, I'm looking at it. Let's see. 2 goes in 18, 9, 27, pi over 27. And then what are you going to get? You're going to get, oh, this is going to be nightmarish. It's going to be 1 plus 9 times 6 to the 4th power to the 3 halves minus 1. The next page, let's look at the answer key. And let's see if I got that. I didn't do the arithmetic though. Let me see if I got the 3 halves, pi over 27. Did I do that? Yeah, we did it. We got it. All right. The only thing I really didn't do, I didn't do the number computation. Well, let's look at number 7. Compute the surface area, revolution. Again, I'm getting a little bit stronger now. And from all the problem working, I want to graph it out, but I guess you could graph it out between 8 and 27. I'm going to write the integration down. All right. So I'm going to write this down real quick. 8 to 27. And then it's going to be 2 pi, the y. Well, what's the y? It's going to be 9 minus x to the 2/3 raised to the power 3 halves times, ooh, this can get nasty. Just over there. The root, I'll put a dx over here. I got to do this over here. So I'm going to write down dy dx equals 3 halves 9 minus x to the 2/3. I got to take 1 from the exponent, right? So it's going to be 1/2. And then I have to take the derivative of the inside, which is going to be minus 2/3 x. I take away 1 from that. So it's going to be minus 1/3. That's nasty. Let's just see if I did it right. So 3 halves come down, 9 minus x to 2/3. Take away 2 over 2, which is 1/2. Derivative of the inside minus 2/3. I think I did okay. Then I got to square it. It's a nightmare. I know that. And what do you get over there? You get 9/4. You get 9 minus x to the 2/3. And if you square this guy over here, what do you get? You get 4/9. Boy, isn't that convenient? And x to the 2/3. All right, this is starting a little crazy looking, isn't it? I notice there's some cancellations though. You get the idea? Now what am I going to do? I'm going to add 1 to it. And what would that give you? It would give you x to the 2/3 plus 9 minus x to the 2/3 over x to the 2/3. Isn't that convenient? What do you get? 9 over x to the 2/3. What am I going to do with that? Take the square root of it. Again, I really should concentrate on the interval it's given me, 8 to 27. Everything's fine in that interval. So what do you get over there? Square root of 9 is 3. And the square root of x to the 2/3 is x to the 1/3. Let me go back up here. I got my eraser out. And this thing turned out to be a lot simpler than I thought. And it's going to be again, looking at it, again, what I'm saying, it's 3 over x to the 1/3. All right. Oh boy, I got more work to do, don't I? And let's see if I can do it. 2 pi, 8/27. And I'm looking at this now, which is 9 minus x to the 2/3 raised to the 3/2. Oh, you know what? I lost the number there. I'll put it in. It's not 2, it's 6. Let me get my eraser. Don't worry, we'll look at the key later. Oh boy, this looks tough, doesn't it? Not really. I guess I could do a U substitution, right? All right, let's take a look. I'll cross this out. I'll let U equal 9 minus x to the 2/3 du. Let's see, it's going to be minus 2/3 x to the minus 1/3 dx. So let's see, minus 3 over 2 du would equal 1 over x to the 1/3 dx. I'm starting to see it now. Let's write this down. So I'm going to factor out now. Let's see, I get the 6 pi and the dx equals minus 3/2 of the du. I'll pull the minus 3/2 on the outside. So it's going to be 6 pi, then minus 3 over 2. That's going to be what? Minus 9 pi, right? Let me do the integration though. If I got an 8, that's going to be minus 9, 8 to the 2/3. Well, the cube root of 8 is 2, so that's going to be 4. 9 minus 4 is 5. And then what do I get? I get the cube root of 27 is 3. That's going to be 0 then. And then you're going to get u to the 3/2, and the dx over 1/3, I've already done that. That's the du. Let's keep going. I know it's problematic. Minus 9 pi. And the anti over there is going to be u. I increase it by 1, so 5/2. And then divide by 5/2 or multiply by 2/5. Limits of integration are going to be from 5 to 0. What's this going to give me? Minus 18 pi over 5. Don't be alarmed yet. 0 minus, well, that's 5 to the 5/2, right? Let me emphasize that 5/2 is 2.5. So it's going to be 25 root 5. Let's do the arithmetic. What are you going to get? We get negative times negative is positive, right? So 18 pi times 25 root 5 over 5. And again, I'm not saying I'm beyond mistakes. I make mistakes all the time. 5 goes into 5, 25, 5 times 18 is 15, 40, 90 pi root 5. I don't know. Maybe I made a mistake. Wow, miracle. Got that one right too. And I really mean that. I mean, I make mistakes all the time at arithmetic. You know, I'll do things like 5 times 5 and I'll say 30. They're crazy things. All right. Things I know are wrong. We just happen to mistake, right? See number 8. Again, I don't know if I want to go through all the details on it, but I'm getting better at this now. And let's see, 1 and E. Looks like a nice little range problem there between 1 and E. You know, everything looks nice and easy there. Let's take a look at, so Y prime, right? Was that going to be 2x over 4? So x over 2 minus, that would be 1 over 2x. I'm going to probably pull that together, right? So that's going to be 2x, x squared minus 1. And then I'm going to do 1 plus y prime squared. And that's going to be what? See if I can do that. Let me do y prime squared first. That would be x squared minus 1 over 4x squared. Let's write this down. 4x squared plus, what's x squared minus 1 squared? That would be x4 minus 2x squared plus 1 over 4x squared. Oh, that's going to be tough here. Maybe not. What do I get over there? x4 plus 2x squared plus 1 over 4x squared. Well, the top is just x squared plus 1 squared over 4x squared. Now, I want to repeat, we're between 1 and a. And this thing's going to behave really nicely. What am I talking about? The square root of this thing. And again, this is a lot of chicken scratch. I realize that. So what do we get over there? Well, the square root of this thing, and that set of numbers are giving me over there, that range of numbers is going to be x squared plus 1 over 2x. I'm going to write this down. 2 pi y. What's y? Oh, that nightmare, right? And we're going from 1 to e, right? All right. Let's just see if we got the right thing. All right. So I'm looking at this, and 2 pi x squared over 4 minus ln x over 2 x squared plus 1 over 2x. Yeah, I do want to point out for a lot of students, they're problematic. But what I'm going to do is, at any point in the problem set, you start saying to yourself, well, I know what he's going to do next. Let me just see what he did next. He pulled out 2 pi, and then what? I guess I multiplied it out, and maybe I should go through that with you. So if I did that, right? Let me see if I could do that. I'll write this over here for you. So x squared over 4 minus, that would be 2 natural log of x, right? And then you'd get x squared plus 1 over 2x. All right, now if you multiply that, what would you get in the bottom? You would get 8x. Again, we're just seeing the next line's good. And then you'd get x4 plus x squared minus 2x squared ln x minus 2 ln x. And let's see if we get that. So the first term would be x cubed over 8. I got that. The next term would be x over 8. I got that. The next term would be 2 ln minus 2 ln x. No, not minus 2, because the 2 cancels with the 8, right? So minus x ln x over 4. That looks pretty good. And the last guy would be ln x over 4x, and that looks pretty good. So then the question is, can you integrate those guys? The first two are pretty easy to deal with. Hope you realize that. The next guy really isn't so bad. I guess you could do that one as well. And then the third one. They do require work, though. These two here require a little bit of work. Here's the deal. If you need me to go through that work, you come by during office hours, and I will be more than happy to do the work for you. I do not mind doing work, by the way. But again, it gets a little tedious over time. Then you have to do the evaluation, the antiderivative evaluation. And I'm hoping you end up with this in the end. If you don't, though, you can say I'm wrong. I don't mind. All right. This one says use a computer algebra system. Before I do that, though, I have to set the problem up. All right. So let's put this down. So I can say between 0 and 3. And it's going to be 2 pi. The y is e to the minus x squared over 2. And then I got to do this thing over here. And it's going to be dx over here. So what do I got to do? I got to do dy dx. I'll write this over here. And that's going to be what? E to the minus x squared over 2. And then the derivative of the inside is going to be what? Going to be what? I have to figure that out. That's going to be minus 2x over 2, which is minus 2x, right? And then I got to do 1 plus that squared, which is going to be 4x squared e to the minus x squared over 2. All right. So what I'm going to do is I'm going to switch screens now, and just be patient with me while I do that. And Let me just see if I did that. Yeah, I got it here. Let me get rid of this thing here, though. You know what I'm going to do? I'm going to share the entire screen with you. All right, let's take a look. And I'm going to clear. I'm going to reset. I'm going to set X to be a variable. By the way, I'm hoping you're taking notes here because I'm just going to copy from my my pad here, integrate. What am I integrating? 2 star pi star e raised to a power. What power is being raised to? Minus x squared divided by 2 star. I don't know, maybe Sage can't do this. Let's see, square root sqrt 1 plus 4 star x squared. Give me 1 second. I don't know if I squared it. You know what? I didn't square it. So I have to correct I'm looking at my notes, by the way, and I'll go back to them later, but I wrote something that's not correct. And when I square that, I'll get my eraser out here. And I just looked at my notes and realized I didn't square it properly. So let's see, 4x squared e to the minus x squared. Again, I'm going to communicate to you again. One of the advantages of having an answer key is looking at an answer key after you do your work, not before though. All right, so I'm going to say 0 to 3. Let's do that. Made a mistake. I hope you see that. And I'm looking at it and I want to see where I made a mistake. And I'm reading it. Integrate 2 star pi star e to the minus x squared divided by 2 square root 1 plus 4x squared. Oh, I see it now. I see it. Wow, it returned it couldn't do it. So it really did return. So I can't do that. So let's take a look. Let's see if I got the right integration down. Oh, what number are we on? We're on number 9, right? And don't worry. I think we did this. I squared that. I squared it 0 to 3. Let me see if I read the right integration down. I'm looking at my notes, by the way. 0 to 3, 2 pi, e to the minus x squared of 2, 1 plus. Let's see what I did there. Oh, you know what? I know what I did. I made a mistake in my derivative, and I got to correct that too. So I can look back at my notes, and I'll correct it. And I made a mistake. There's no doubt about it. And I'm glad I made a mistake. So I got to erase a lot of stuff in my notes. But I'm going to go try that again after I correct my mistake. And I'll go back to the whiteboard later. So I realized I made a mistake in the derivative. And the derivative was, the reason it just, I guess, tired. So I'll discount that. So it's going to be e to the minus x squared over 2. And the derivative of the inside is going to be minus x. When you square that, you would get plus x squared e to the minus x squared. All right, I'm going to correct it. And let me do that over here. So it's x squared e to the minus x squared. Get rid of this 4 now. All right, still didn't do it. All right. So the question becomes is, I wonder why it didn't do it. And someone can say, I think I really need to force it to do it. And I'm going to try to force it now. So I'm going to force it by saying, could you please give me a decimal? And I got it. It gave me the decimal now. So you notice I put the dot n at the end of it. I was saying, please just give me a decimal approximation to the answer. And it does it. What does it give me? 8.565. All right, let me go back in the notes and I'll talk about what I did that was incorrect with the derivative. Give me a second. Okay, so originally I wrote the wrong derivative down and I wrote the wrong square down. All right. But I fixed it. All right. I just fixed it. I fixed it in my notes. How do I do that? You're right. I looked at a key. I made a mistake. I said, gee, something's wrong with this. It's not looking the same. And I try to figure it out. But we did figure it out. I want to go to the next page. Next page where they're giving me Sage code over here to do it in. Here's the deal though. Sage is not going to be any help to you at all unless you can formulate a problem like this. You need to get to this stage over here. So this is the really important part. This is important. Sage is not going to do that for you. And by the way, you should fear that time when machines can start doing that. Machines can think through problems. And really, we're at this stage where, machines are getting better and better at doing stuff. They really are. But please, you got to get to that stage yourself, though. Machines will be competing against you soon. All right, get to that stage, compete against the machine, so to speak. Thank you for listening.